What's that? In the sky? Is that a plane? Hello, in this video we're going to be discussing why the center of gravity is important to be taken into consideration in aircraft, its effects on stability and performance. And in order to do that, we're going to need a basic understanding of lift and center of lift, also known as center of pressure. So here we have our equation of lift brought to us by NASA and the Glenn Research Center. And one of the key takeaways here is that lift is directly related with velocity squared, right? So as our velocity increases in our aircraft, our lift increases. So in order to have more lift, we need more velocity, right? This is a good time to also go into what the center of lift is, also known as the center of pressure. The center of lift is the location of the sum total of lift forces acting on the aircraft. So in this image, I suppose that this could represent the center of lift. So here we have two different configurations for our aircraft. In the first one, as I have labeled balanced, we have the center of gravity forward of the center of lift, and in the second one, we have the center of gravity aft of the center of lift, right? So in both scenarios, now let's start with this one. Let's imagine that we have a gust of wind hitting our aircraft, right, from the front. So this aircraft's going to have a tendency to do this, right? Our center of lift is going to kind of want to push it this way. Center of gravity is going to want to push it this way. And let's say our tail force that a pilot applies is going to push it this way. Regardless, in this configuration, we have a tendency for this aircraft to turn clockwise, okay, in this configuration. This is known as a positive static stability. In this other scenario, we have a gust of wind pushing us. We have a center of lift kind of doing this. We got our center of gravity kind of doing this. And our tail force could be doing whatever it wants. But regardless, in this scenario in which we have the center of lift forward of the center of gravity, we call this unbalanced, or also known as having negative static stability for our aircraft. So here we have a representation of a balanced configuration having a positive static stability, right? So we got our center of gravity and we got our center of lift, and our center of gravity is forward of our center of lift. This black line right here, or this arrow, represents a downward tail force being applied by the airplane pilot, right? So let's get started. So this yellow bar right here represents the range in which our center of gravity can be located, and we could still have some safe flight. You know, this is determined by aircraft manufacturers, and they determine that this is where we need to be. It's in this little envelope here. So now let's imagine a scenario in which all of the bowling players in the back of the aircraft, because we got a bowling team, brought all their balls with them, all their equipment. It's very heavy, and they're all sick of sitting in the back. So they all decide to just move to the front without asking. So they just move to the front of the aircraft, and therefore this moves our center of gravity forward, right? So what does this do for us? So this is going to kind of cause our airplane to have this tendency to do this, right? So in order to counteract this, you know, our airplane pilot might want to increase the tail force downward, right? And this is kind of pitch our airplane up. But now that we're doing this, we have more forces acting downward, right? So in order to counteract this, we're going to need to increase our center of lift force, or rather our lift force. And two things are at play here. We need to increase our center of lift. So we increase our angle of attack, right? Oh, sorry, we don't need to increase our center of lift, we need to increase our lift force. So we increase our angle of attack. So what's happening right here? We went from having drag force being applied to this frontal area to even greater frontal area. So this is increasing the drag force on our aircraft. This is in turn going to consume more fuel. If you guys remember at the beginning, we discussed that in order to have more lift, you need to have a greater velocity. So let's say that the pilot in this scenario, along with increasing the angle of attack, decides to also increase the velocity in order to adjust for that extra necessity of lift. So now we're going faster, we're spending more fuel because of it, and we're spending more fuel because of the amount of drag that's being created. So then one might say, uh-oh, well, I don't want any of that, so let's just always keep the center of gravity as close as possible to here. Well, that could have some adverse effects as well. If you can imagine, this line right here is the distance between our center of gravity and our downward tail force, or our tail force, right? In this location right here, we have a rather small distance between this force and our center of gravity force, right? So this would mean that a smaller force here on the back of the aircraft would have a greater impact against counteracting this force right here, right, with the moment. So now let's imagine that our center of gravity is over here. Well, now our pilot could move the location, or rather the amount of force being applied on our downward tail force, with much more finesse, right? So they could increase it much more, right, going downward on our downward tail force right here, and it wouldn't have such a great effect on the moment, a balancing act that we're kind of doing here with our center of gravity. So this in turn adds longitudinal stability to our aircraft, right? And yes, there are different scenarios in which somebody might, prefer to have less stability. So let's say somebody wants to perform some acrobatic, maneuvers. So then they would want to have to move it less, be able to go much faster as far as making these changes in a swifter fashion. So then they might want this. But overall speaking, having the center of gravity more forward and within that envelope would increase the stability of the aircraft. That's it. Thank you for watching. If you guys have any questions or concerns, make sure they drop a comment down below. If you think that I'm wrong about something, please let me know. I will take this video down and I will correct it and re-upload it and give you all the credit in the world. And as always, thank you for watching.